All right, this is Applications of Quadratic Functions, Part 2. And I've written up today's example. We have here Joe and Stan each bikes 6 kilometers. Joe bikes 3 kilometers per hour faster than Stan. Joe starts 3 minutes after Stan, and they finish at the same time. Now that's because Joe's faster, right? He's 3 kilometers per hour faster. How fast is each guy going? So these typical type examples involve distances. We got 6 kilometers here as a distance. There's some talk of speed, and there's some talk of time. So really what you want to do is you want to gather up your data. And we've got 2 categories here. There's Stan and there's Joe. And we're also dealing with distances, and we're dealing with speeds, and we're dealing with times. So basically we want to fill in this table here, okay, with these 2 different categories. Now I'm going to use a very important little relationship. All speeds or velocities, like say 80 kilometers per hour. Now kilometers is distance, per hour is time. So kilometers per hour, and that was like 80 kilometers per hour. This is our relationship, and it's a way to minimize the amount of variables when we fill in the table. So let's put in some of the stuff we already know. Both of these guys travels 6 kilometers. Okay. Now, as far as speed goes, we know that Joe is a little bit faster, right? So we're gonna say that Stan is traveling at X kilometers per hour, and that means Joe bikes 3 kilometers per hour faster. So his speed would be X plus 3. As for time, what I'm going to do is use the relationship over here that distance divided by speed equals time. So here's what I'm basically going to use. If you just take a distance and divide by the person's speed, that's equivalent to time. So here we have Stan, and that's 6 divided by X, okay, distance over speed. And down here this would be 6 divided by X plus 3. Okay. So now that I've filled in my table, I'm going to try to make an equation. And the only other bit of information I haven't used yet is this 3 minutes business. Okay. So we don't know how much time Stan and Joe need, but we know that Stan is 3 minutes longer on his bike than Joe, right? Because Joe starts 3 minutes after Stan. So Stan's already been going for 3 minutes, then Joe starts, and then they finish together. So Stan's going to have 3 more minutes than Joe. Now, just one quick thing here. This 6 was in kilometers, and the speed presumably here, since we went X plus 3, and that was kilometers per hour. So I think as far as time goes, we're talking about hours here. So you really got to be careful, because when we talk about 3 minutes, you can't just go mixing minutes with these expressions which are in hours. So I'm going to be converting this 3 minutes to hours when I build my equation. So let's just see, we can probably squeeze our equation down here. Here's Stan's time. Okay, so there's the amount of time that Stan is on the bike. And here's the amount of time that Joe is on the bike. Okay. Now we know that Joe is a little bit faster, right? He started 3 minutes after Stan. So what we got to do, this is actually the smaller amount of minutes. So if I add 3 minutes to it, but I got to be careful, that would have to be converted to hours. So 3 minutes means 3 out of 60 minutes. Now we've got it in terms of hours. That should equal the amount of time that Stan is on the bike. So this is my equation. And I think if we are skillful, we can solve this and figure out how fast these guys are going. So I'm just going to try to keep my equation on the screen and see if I can delete all this stuff, which I don't really need. Okay, so let's see if we can clear that. And now I'm going to start solving this. Now the first thing we're going to want to do is get rid of the fractions. And I've got denominators of x, x plus 3, and 60. Oh, let's simplify this a little bit. We'll divide the 3 into the top and bottom. And that just makes life a little bit easier dealing with smaller numbers. Now I'm going to multiply everything by x, x plus 3, and by 20. And I'm going to put the 20 out in front. Just looks a little bit neater. So that is going to times all of these fractions. So I got 6 over x, and we're going to multiply it by this guy here, 6 over x plus 3, and also by the 1 over 20. Now this is cooked up so that all of these denominators should cancel. So my first term, the x on the bottom, cancels with the x that's out here, and that's going to leave me with the 20 and the x plus 3 and the 6. I guess I could write it over there. Okay, and we'll clean up that mess on our next step. This next term here, well, the x plus 3s are going to cancel, so I'm left with 20 and x and 6. So 20 and x times 6. And then at the end, all that cancels are the 20s. So we've got the x and the x plus 3 still in the running. So now I'm going to try to expand the brackets, and it's probably easiest to think of this as 120. So I'm just going to write that down. This is what I think makes the job easier. I'm just going to go 120 times what's in the brackets. So I've got 120x plus 360. And then this one here, I'm just going to multiply the 20 and the 6 together. So 120x plus x squared plus 3x. Okay, so we're definitely getting a quadratic equation. And here's our x squared term. So I'm going to move everything on to the right side. Make sure I got 0 on the left side. So let's see what's coming on over. We've got 120x and 120x. Hey, why don't we just subtract 120x from both sides? And that leaves me with plus 3x. And then I've got this 360, which I'm going to subtract over to this side over here. So I got minus 360. All right, so we've got our quadratic equation, and we've got it equal to 0, so we're all ready to go ahead and solve. Now, I always like to try factoring, and I already worked on this one, and I tried to factor it, and I could not get it to factor. So what do you do if you can't get it to factor? Well, let me show you. Our fallback plan is always, and for some people maybe it's the way to go, your old buddy, the quadratic formula. So nothing wrong with doing that. Here's b, so we're going to have negative b, whoops, here, let's get rid of that. I don't want to write b, I want to write negative 3, so try that again. So we have negative 3 plus or minus the square root of 3 squared minus 4 times a, which happens to be 1, and c, which is negative 360. So be careful you don't lose that negative there. And all of this is over 2 times a, and a is 1. So this is what I've got to simplify and get my solution. So negative 3 plus or minus the square root of, and we'll do the easier one first, that's just a 2. All right, if we plug this into the calculator, which I already did, 9, and then the double negative becomes plus 4 times 360, I ended up with 1449. Okay, and you can see this is going to give us some answers, but I'm going to turn them into decimals so I can see what these answers are. Just remember to make sure you do all the stuff on the top before you hit divide by 2. So you got to make sure it's negative 3 plus the square root of 1449. Calculate that number and then divide by 2. If you do this, you get 2 solutions. One of them is 17.53. Okay, and then the other solution is if I go -3 minus the square root of 1449, calculate that number and then divide by 2, and you get -20.53. And you can see why it didn't factor, because we're getting decimal numbers. Now, it's off the screen here, but if you go back to your table, remember what x represented. This was Stan's speed. Well, there's no way his speed is negative. So we're going to reject this solution here. And so the only answer that kind of works is this one. Even though it's ugly decimals, it doesn't really matter. I can now tell you what is Stan's speed and what is Joe's speed. So we just always want to give our answer here. So we make sure we got it. X, if you look in the table, X was Stan's speed, and X is 17.53, and this is kilometers per hour, which I'm not sure I can squeeze in here, kilometers per hour. And remember that Joe's speed was 3 kilometers per hour faster than that, so it's simply a matter of adding 3. So he's traveling at 20.53 kilometers per hour. So there's our answers. There's Stan's speed and Joe's speed, and we've solved this question. Okay, that's where I'm going to stop, and we're going to continue with one last applications example.